Hi guys, welcome back to another video on fractions. In this video we're going to continue on with multiplying fractions, but looking at how we would cancel a fraction down so that it's easier for us to multiply. So when we cancel, there are two ways that we can do this. There's two kind of rules. The first way, and we have our fraction here, now these little circles would represent any number depending on what our sum is. But our first rule is that what we call cross cancel. So we can cancel this number here with this number here. And same here, we can go this denominator with this numerator. The second way we can do this, and we have done this a little bit when we've worked with just one fraction, but now we can do it with two fractions where we cancel the top and the bottom of one fraction. And then we do the same, we can either cancel the top and the bottom of this fraction as well. Now what you'll notice is that every time I've cancelled it, it's one denominator with one numerator. Again, one denominator, one numerator. Okay, it's not two numerators or two denominators being cancelled, it's one of each. So let's use those rules to help us solve these examples. So 2/5 times 5/7. So we're going to start by cancelling. We're going to use this method here. So we go 2 and 7. Now we're looking for the highest common factor. So the number that multiplies by another number to equal 2 and then to equal 7. So we're looking for the highest common factor of 2 and 7. Now because 2 and 7 are both prime numbers, the only highest common number we have here is 1. And if we were to simplify using the common factor of 1, there's no point because we'd still have 2 and 7. So we just leave those ones. And we look at our 5 and our 5. And here, our highest common factor is 5. And we say, well, how many times does 5 go into 5? Well, that happens once. And how many times does 5 go into 5? Well, that's once again. So what we do now is we rewrite the sum, replacing those numbers that we've cancelled down. So we've got 2 over 1 times 1 over 7. And if you remember from the previous video, we multiply our numerators and then we multiply our denominators. So we end up with 2/7. Let's do another one. So again, let's look at cross multiplying. So 8 and 9. Are there any common factors of 8 and 9? Well, no. There's no highest common factor of 8 and 9 other than 1. That is the highest common factor. And there's no point using 1. 10 and 3, well again, there's no other factors other than 1 for 10 and 3. So this method here doesn't work. So we're going to move on to this method. So we have 8 and 10, and we have 3 and 9. So now what we're going to do is look for the highest common factor of 8 and 10, which is 2. So 2 goes into 8 4 times, and 2 goes into 10 5 times. And again, our highest common factor of 3 and 9 is 3. And 3 goes into 3 once, and 3 goes into 9 3 times. So now we're going to rewrite our sum, which is 4/5, because we've replaced it with what we've cancelled. 4/5 times 1/3. Then we multiply across and we end up with 4 times 1, which is 4, and 5 times 3, which is 15. So we end up with 4/15. Now our final one, where we have our three fractions multiplied by each other. So this one might look a little bit daunting. There's 3, but we can still cancel. So we're actually just going to use this cross cancelling method. And we just have to remember that as long as there's one denominator and one numerator for each cancelling, then we're good, okay? So we're going to start with 3 and 9, okay? So one numerator, one denominator, and I know that those two there have a common factor. Then we're going to go for 10 and 5. Now you could go 4 and 10, but that would leave 5 without being able to be simplified, and it would mean we simplify it later, but you could still get the same answer. And then our last one is 4 and 8. So you want to see how many pairs can you make. Now we're going to look for the highest common factor of 3 and 9, which is 3. And 3 goes into 3 once, and it goes into 9 3 times. The highest common factor of 10 and 5 is 5. And 5 goes into 10 2 times and then into 5 once. And then the highest common factor of 4 and 8 is 4. And 4 goes into 4 once, and it goes into 8 twice. Again, we write this sum out, replacing our previous values with our new cancelled down values. So we end up with 1/2 times 1/3 times 1/2. Again, we multiply the numerators and then multiply the denominators. So we end up with 1 times 1 times 1, which gives us 1. And 2 times 3, which gives us 6, times 2, which gives us 12. And so we end up with 1/12. We're going to do one more little question. We do a little bit of cancelling out, but we're looking particularly at multiplying mixed numbers. Now, when we're multiplying mixed numbers, the first thing we do is convert all the mixed numbers to improper fractions. Okay, you must do this. Then what we're going to do, so we get, 3 times 5 gives us 15. And then we go 15 plus 5 is 18, so we get 18/5. 1 times 9 is 9, plus 2 is 11, which gives us 11/9. So now we're going to cross cancel. So we have 18 and 9 here, and we can see that a common factor is 9. So 9 goes into 18 twice and into 9 once. Then we can look at our 5 and 11, but there's no common factors here because they're both prime numbers. So again, it's only 1 that is the common factor, and we don't bother doing it with 1 because, well, 1 goes into 5 times and it goes into 11 times. So let's rewrite it now, replacing those values. So we end up with 2/5 times 11 ones, 11 over 1, and then cross multiply again. So we get 22/5. Now, what do you notice about this? Hopefully it's that it's an improper fraction. So remember, we always simplify. Improper fractions are not simplest form. So what we're looking for is how many times does 5 go into 22? And it goes in, I think I made a mistake. It goes in 4 times. And then we have 2/5 remaining. Oh no, I got it right. 4 and 2/5 remaining. Fantastic. If you guys have any questions, make sure you ask. Otherwise, I'll see you in the next video. Thanks, guys.